Alright, time for another DraftPhysics.com. DebatePhysics.com also, but debate, hard to find. Anything rational or on the subject, taking into account the arguments that have been made and making counter arguments. People are just incapable of that. So this iron doxing supporter person has done another wacky video claiming that he's proving, okay, he says proof of 4 mass dropped 1 foot is the same energy, it hits the ground with the same energy as 1 mass dropped from 4 times the height with twice the velocity. So he uses the words velocity, 1 velocity versus 2 velocity. And yeah, it's frankly, I don't know if physicists will say it. I haven't found any physicists who will say that's true. I suppose indirectly, maybe physicist Michael conceded that he believes it. I can't remember exactly. I remember one of the experiments he did say was valid when it made such an accusation, I think. But whatever, it's too ridiculous almost. You're almost like, come on, you can't be this silly. But apparently they can be. All right, and he's such an idiot and a jerk. I'm not going to play his video because he can't be reasonably decent. So I'll just paraphrase his terrible, awful, foul, disgusting argument, and point out that I already provided evidence. Okay, now I'd say it's a proof from my perspective, but I provided evidence. I didn't claim it proves anything. I just provided it as a piece of experimental evidence. But I did do this. I created a balance, a very nice balance. And it had a fulcrum, and I put 4 mass here, and I put a 1 mass 4 units of distance, which meant this moves 4 times as much. Okay, it's 4 times the velocity of this. 4 times the velocity. 4x the velocity. And this is 1 velocity. So for every unit of distance here, there's 4 units of distance here in the oscillation. And you just oscillate. You can put the energy in this way, or you can put the energy in this. It doesn't matter where you put it in. And it'll oscillate. It's a balance. And it'll show you that the motion of a 1 mass doing 1 velocity is exactly equal to a 4 mass. Gee, why did I put 4 out here? Yeah. The 4 mass going 1 velocity is directly equal to the momentum, the energy, the weight of a 1 mass. And it just proves it. The scale balances perfectly. You can put energy in and it'll oscillate and then it'll stop and it'll perfectly balance. Demonstrating that these two things are equal. These two quantities are equal. 4 times the movement over here is equal to 1 movement over here. Okay, no doubt about it. So this is just a redrawing of that, so we probably don't need that. But I made the accusation in the past. Oh, interesting. Computer failure. Annoying. Alright, should be continuing. Anyway, irritating computers. So I've pointed out in the past that, there's this kind of simple, idea of an experiment where you just have a lever and you put a mass here, let's just say a 2 mass, and you press here, okay, and just see what it feels like. And that technically, this is 1 unit of distance, that at 2 units of distance you could put a 1 mass, okay, and it will feel the same as the 2 mass. It's twice the velocity. It's twice the weight, essentially, because you're moving half the mass, twice the velocity. That's the momentum. So it would feel exactly the same. And if you wanted to make the 1 mass, okay, if you made this a 4 mass, okay, obviously to feel the same as the 4 mass, I have to have 4 times the velocity. So I'd have to go out here. And that's where I have to put the 1 mass, and that's what I did up here. 4 times the velocity, 1 velocity, 4 times the velocity. And those two will feel the same is my accusation that I've done these experiments, okay? That's how scales work. The 4 at 1 unit of distance moving 1 velocity is the same as the 1 moving 4 velocity. Not 2 velocity, 4 velocity. Okay, those two equal each other. So at 2 velocity, it doesn't work. So if I did the 4 here, okay, and I put a 1 mass at 2 distances, so let's see if we can find a good, here's your fulcrum. So that'd be 1, let's say this is 2 distances, and I put the 1 mass here, it won't balance. The 4 mass will go swing down here, and the 1 mass will go swinging up here, and it won't balance. But it will balance if I put the 1 mass 4 units of distance. That's the truth. I did it. Okay, there's no doubt about it. So anyway, so Gosling says he's proven otherwise. Okay, and this is his... I mean, it's such a ludicrous Rube Goldberg pile of crap experiment. I mean, so unclinical, it's incredible. So he has some rotten, crappy piece of broken wood. Right? All right, he's got poles with weights. Now, he doesn't tell us how much these poles weigh. Okay, so he doesn't say a damn thing about that. And he has to put a weight on them to compensate for the fact that part of the momentum is in the poles themselves. So as was pointed out before, you have to compensate. So before he had a 1-to-2 relationship. Now he's supposed to do a 1-to-4. So he's supposed to have a 1 mass and then a 4 mass. So now he has 1, and let's say this is 0.5. He has 1.5, okay, to 4.5. And he has to have 4 times 1.5. So he has to have 6 here. This has to be made into a 6. To make this a 6, you have to add 1.5 in mass now. Before he only had to add 0.5 when he was just doing 1-to-2. But now he has to add 1.5. So he probably didn't even do that. He didn't even figure out what the extra mass is he needs to add to fix the momentum issue. Because he's really stupid. Not much else to say. So anyway, so he can't do that part right. Now the other part of this experiment is that he's doing the masses are apparently the same profile. So the fact is that if he has a mass that's a 1 mass and a 4 mass, then I can draw it over here. The surface getting hit is apparently 4 times bigger for the 4 mass. You know, it's 4 times the size of the surface area hitting the surface. Alright, so he has this dummy block of wood, and then he put a piece of foam. You know, foam with little air bubbles type foam. Kind of foam. But it doesn't look like it's stiff foam at all. So it's not like the rubbery kind of foam. It's like an airbag. It's like the really slow moving kind of foam. So it's just an absorber of energy, frankly. All it's going to do is absorb energy. It's not going to push the energy in because it has such a low spring constant. It has such a low stiffness constant that it's nothing like a spring. It's not going to create an inelastic collision. It's just going to absorb energy, frankly. And it's clearly more likely to absorb the energy from the thing with 4 times the surface area, okay, that's hitting at, you know, half the speed. Obviously at half the speed it's significant. You know, it's a big difference. So that's really stupid also. That he would expect to get the same results. So it's a block of wood that he intends to tip over. Now what does he do in the experiment? Yeah, he just tips them both over. And he just pretends, well, this one tipped over and it, you know, it fell and went boom, and this one fell and went boom. And so therefore I've proven it. When I didn't prove anything. He could have moved the heavier mass closer and it still might have fallen over. Who knows? He didn't do an experiment where it didn't tip over. He just did 2 different experiments showing that it tips over from both points when that doesn't prove anything. It doesn't demonstrate that one has more energy than the other at all. So, I mean, there's like 1, 2. the very idea of using a block of wood and tipping it is also suspect. The surface area that's hitting the foam, okay, suspect. The stupid pole's hole he's using as part of the momentum, stupid. All of that, he says, undoes, okay, proves that scales are wrong. So balances are lying to you. Okay, so when the balance says, just draw it one more time, when the balance says 4 pounds here equals 1 pound, 1, 2, 3, 4 units of distance, which is 4x the velocity. You have to be 4 times the velocity. This is 1 velocity here. It moves this much in space. And the same force, the same exact force, moves this 4 times as much. 4 times as much. 4 times the velocity equals 1v with the reciprocal mass. Not here, okay? This doesn't work. This isn't twice the energy. I mean, this isn't the same energy as this. Twice the velocity will not equal 4 pounds dropped 1 velocity will not equal one thing with twice the velocity. It has to have 4 times the velocity. And dropping it 4 times the height doesn't give you 4 times the velocity, as everybody should agree. So it's just bullshit. He's not going to prove the scale wrong. He's certainly not going to be able to explain how the scale is lying, how it's giving us a fake result. It's a scale. It's kind of overt in its statement. It tells you what equals what. That's its whole job, is to tell you what equals what. And it's clear that 1 with 4 times the velocity equals 4 with 1 velocity. That's what it's clear it's saying. Not just twice the velocity. Twice the velocity is not the same. 1 pound moving twice the velocity is not the same energy as 4 pounds moving 1 velocity. It's just not true. And he hasn't proven that it is. Yeah. So let me think if there's some other way to test this. Unfortunately, see, that's the whole problem, right? You can't Google it. So I can't find any sources where somebody actually argues from an experiment, where they actually drop, 4 pounds from 1 inch, and then 1 pound from 4 inches, and prove that they weigh the same. They hit the scale and make the same dent in the scale. No evidence from that. And clearly it would be better to do it this way, because then you don't have to worry about the actual weight. You don't have to subtract the weight of the object from the impact momentum. If you drop the weights, you have to subtract 4 pounds from the first weight, and you have to subtract 1 pound from the second weight. So it's a tiny bit complicated, but it's really, this isn't too much, right? It isn't too much to say that, in physics in 300 years they couldn't do this experiment. They couldn't do it. Couldn't manage to get that job done. So there's just nothing. There's no video evidence of any reasonable experiment, where they don't have block of wood, foam, plastic tubes, uneven surface area getting hit. Yeah, no, we don't have an experiment better than that. And clearly I would argue when I did the pendulum, it perfectly oscillated the balance. Game over. I mean, it's a perfectly valid way of measuring energy, is to put the things on a scale, cause them to oscillate, and you can see what things equal what, because they will oscillate consistently. They'll balance. I mean, I can't say it any clearer than that, I don't think. So I'll think for a bit and see if there's anything to add here. But I'm just saying, I tried Googling 4 pounds, 1 pound, this, that, trying to get something, and there's just nothing. So they really don't account for Leibniz's theory at all. And again, I haven't heard too many physicists ever say that they actually believe that if I did drop 4 pounds from 1 foot and then 1 pound from 4 feet, that the two things would make the same impact on the ground. They dent the ground the same amount. No real chance. Unless, of course, you want to play with clay and use round objects hitting clay. Unless you want to do some kind of bullshit. But anyway, it's just, they're so arrogant, so obnoxious when they have so little evidence. Alright, well, I thought of something that might help, but I don't know. I mean, they're so belligerently stupid. So let's say, okay, that this is my center. Alright, right here. And I did rotate this, say, in space. Okay, I gave it energy and it was rotating. Alright, this is going and this is going. So this is going the big arc 4 times for every 1 unit of distance this travels, this will out here will travel 4 units of distance. So we're, guaranteed that the velocity will be 4 times the velocity. And let's just say that at some point I just put a stop in, and now the lever stops dead. So all of its energy is ceased. And these things are free now to fly off. Does he really think that this is going to go something other than 4 velocity? The one object will go 4 velocity, and this object, the 4 object, will go 1 velocity. Is there really any hope that anything else will happen? That the 4 pounds will be going 1 velocity, and the 1 pound will be going 4 velocity? Is there any hope, any reasoning, anything he could offer to explain that that's not going to be the outcome? That that's exactly what the outcome will be? Yeah. Like I said. All right, I guess I should add to that. See, there's always some little complication. You always have to take account for it. So if I did do this in space, okay, with this relationship, the 1 to 4 at these locations, 4 times the distance, 1 unit of distance, and I spun that in space, the truth is it would stay right where I spun it. It would just spin right there because it's balanced. Now if I move the 1 mass here, okay, then it's going to be imbalanced. It's going to have more weight moving on one side than the other side, and so now it's going to perturbate. It's going to start processing as it rotates. So if I spun it, because it's imbalanced, it's going to start processing, start moving in space. So it won't stay in the space I put it. So if I take a unbalanced wheel and spin it in space, it's going to process. If I take a balanced wheel, it's not going to process. So does he really think if I put the 1 mass, 4 units of distance, twice the velocity, 4 times the velocity, it's 4 times the velocity, and the 1 mass, 4 mass at 1 velocity, and I spun that wheel in space, does he think it will process because it's uneven, it's broken, it's lopsided? No. We know it's not lopsided. We know it's balanced because it balances. And we know if we put the 1 mass just 2 notches, only doing twice the velocity, that won't be good enough. That'll be less mass on one side than on the other side, and it's going to process. All right, maybe one more argument. So, we've been sort of over this thing. You could, dropping stuff, pushing a scale with gravity, putting a weight on a scale and having it show up as a weight is really measuring momentum. But everything you put on the scale is moving a velocity, and that's why it weighs its atomic mass, is because it's in gravity, and we've established that those things are the equalities. But everything, no matter what I put on here, it will register a correct weight because it's only going to collect, based on how much mass is in the object, the force. And it's the same thing as this. It's the same thing as moving something a velocity. So the fact is I can duplicate this mass, going this way. That is, if I move an elephant 1 mile an hour, I'll get the weight of an elephant. If I move a mouse 1 mile an hour, I'll get the weight of a mouse. A pair of pliers, I'll get 1 mile an hour, I'll get the weight of the pair of pliers. This weight, gravity's weight, will equal this weight. Because in fact, 1 mile an hour is the weight, the velocity you actually have when you're not moving. And you actually have it because obviously you could do something simple, like you could go into the ground faster than the ground pushes you back up. But it's always pushing you back up. So it always restores your position. And the net difference is 1 mile an hour. That's a simple way to understand it, I think. So regardless. So his theory is, okay, is that if I compress this thing enough to make 4 ball bearings, I'll put 4 ball bearings there, push off at 1 mile an hour, that if I put 3 ball bearings, okay, it won't go 1 1/3 miles an hour. And if I have 2, it won't go 1 1/2 miles an hour. And if I just put 1, it won't go 2 miles an hour. I don't know if I said that right? Quarter, half. The point being that it's proportional. Okay, that you have to go 4 times faster. So I should have done it the other way around, right? So the 4 goes 1 mile an hour. Okay, so the 4 of them jump off at 1 mile an hour. I compress it the same amount, but only put 3 in front of it this time. Then it's going to be 1 point. it's going to be 1 1/3, right? Miles an hour. No, it's going to be twice the velocity. And then 3 times the velocity, and then 4 times the velocity. So as I reduce the number, the velocity will keep increasing. So yeah, so 1, all 4 of them, it's 1 unit of velocity. 3 is 2 units of velocity. 2 is 3 units of velocity. Yeah, no, that's something's wrong there. And 4 would be 1 unit of velocity. Well, anyway, yeah, I'm probably saying that wrong. I'll think about it. Alright, well, every video is kind of good because sometimes you learn something, So, I guess I'll erase because you can't really see anything. So I was thinking about what I just said, and I didn't like the way it sounded. So I guess that's the old intuition thing now and then. It's helpful. And that something about this didn't make any sense. 4, 3, 2, 1. Because this comes out to 6, and this is 6. And then this is back to 4 again if you do the multiplication. So it doesn't really work. So what really happens, so the idea is you have a scale and a spring. And so you compress the scale first by just having the 4 masses on it. And you get that amount of compression. So you know that's the compression you're going to use. And you turn the scale sideways. And so with the 4 objects, what you're going to end up with is enough pressure to move them 1 mile an hour. Because that'll be the same as gravity. I'm saying 1 mile an hour. Could be a little less, could be a little more. But it's going to be pretty close to 1 mile an hour. All right. And so it'll go 1 mile an hour. All right. Now if I only put 3, if I leave the same exact compression, okay, so we have a standard force, and instead, okay, I just put 3, it's not going to be 2. It's going to be, this velocity will be 1.3 miles per hour. Because it's not an even division. So it ends up being 1.3 will be the velocity with the 3 mass. And then if I just have 2, okay, then it's going to be the easy one where, yes, it's half the mass. It'll be twice the velocity. So it'll be 2 miles per hour. And then obviously if I'm going to do 1, it's going to be twice as much as half as much as 2. So obviously it's going to be 4 miles per hour. All right. So that's the correct, this is the correct formulation. Okay, 4 to 1, 3, 1.3, 2 is 2, 1 is 4. So that, the momentum's all equal. This didn't work. Okay, so that was wrong. So, interesting. I found it interesting anyway, as a thought experiment. So we're still okay with the 2-to-1 relationships in terms of half the mass, twice the velocity. All those still work. But it's when you start changing the mass by some uneven number, yeah, it really does change how it works. The number isn't going to be halfway between the two. It's going to be less than halfway between. 3 is closer to the 4 and further away from the 2. It's not in between the 2 mass and the 4 mass. It's not 1.5. It's 1.3. Okay. So anyway, interesting, I think. So enough of a video, but, clearly nothing has been proven with anything called credible evidence. So in 300 years, they haven't managed to prove that the momentum of 4 pounds moving one velocity is the same as the momentum, the weight of force, the force of 1 pound going twice the velocity. Obviously, 1 pound has to go 4 times the velocity. 4 v. All right. Until the next time and such.